Hello everyone, welcome back. Congratulations for reaching this far. We finally got to the last part of this lab. This lab was very huge. It has been broken down into different stages. Now we are now going to configure the final part, that is the WLAN, to enable the wireless users to be able to access our network. So let's see the lab requirement. A WLAN configuration. Wired network configuration. Configure the switches on the enterprise intranet so that AP can communicate with the AC and STA connected to the AP can communicate with the gateway, that is the firewall, after connecting to the WLAN network. So after connecting to the WLAN, the STA should be able to get to the firewall, that is, should be able to ping the firewall's gateway. Perform the bottom layer network configuration on the AC so that the AC can communicate with the AP. The AC functions as the DHCP server to allocate IP addresses to the AP and STAs. And WLAN service requirements on the WLAN side. The AP and AC reside on the same network segment, and AP directly registers the AC at layer 2 and forwards traffic from the STA through the AC. The AC functions as the DHCP server. So this lab, we will do it very quick because this one is not so complicated, because when we look at this requirement, couple of source will be on the same network that VLAN 19 for the AP is. So this one is very simple, but in a situation where that is a layer 3 where the couple source and the AP IP is on different network, that is AP and AC are on different network, there is where sometimes we find a very difficulty, but it's not that difficult. For that lab, you can look on the channel. There's a video for 2019-2018 lab where they were testing on different IP addresses for the AC and AP. So you should check on that and see how you can do that in such a scenario. So this one is the one we are going to configure. So first of all, we were told to ensure that now there is communication within the switches. So these switches will just act as the forwarding, because AC and AP being on the same network, the switches will just forward the traffic. So there will be no routing on the switches. They will just do the forwarding. Before we do anything, before we proceed, we're going to stop our AP and copy its MAC address. Stop and copy its MAC address, which we are going to bind to the AP group. So come to settings, configurations, then copy MAC address. You can either use serial number or MAC address. We are going to use MAC address. Then paste that MAC address, Control V. Make sure you group in a group of 4. So once you copy the MAC address, you can start back your device. So let's just go and configure our AC. So on the AC, we have got 2 VLAN, that's the management VLAN and the service VLAN. So we are going to start with the DHCP. Then global for pool, the name is STA. So let's begin with that. So say IP pool name here will be for STA, for AP, for underscore AP. Then the network where that resides will be on a network of 192.168.19.0, while for the STA is 192.168.2.0 with the gateway 192.168.2.254. So network here will be 192.168.2.254. 19, that is for VLAN 19.19.0. Mask here is 24. The gateway, they said gateway list here will be 192.168.19.254. That is the IP of the CAPOP source. Then you can also give it a DNS list. So we can set a DNS list here. Let's give it 14.14.14.14. Those one were not you are not told, but you can implement yours. Also, you can give it a list day. So you can say the IP should be list for a period of 1 day. Day 1. Hour should be 12 hours, and also how many minutes should be given. 30 minutes. So should be given 1 day, 12 hours, 30 minutes. After that is done, we can create a pool for STA. So IP pool STA network will be 192.168.2.0 with a mask of 24. Gateway list here will be 192.168.2.254. DNS list, let's give it 14.14.14.14. After give a DNS list, let's give it the list day 1. Hour is 12 minutes. Yeah, it will be 30. Then we are going to enter the interfaces and allow global on the interfaces. As we proceed here, we have been told that IP address of the AC source interface VLAN 19 will be 192.168.19.254. So we are going to create sub VLAN interfaces, that is for VLAN 19 and VLAN 20. For VLAN 19, its IP address will be this one. But for VLAN 20, they have not given you IP address for VLAN 20, but we will take the IP address 192.168.2.254. That will be the gateway for VLAN 20. That one will act as the IP address of the VLAN interface. So we create and enter interface VLAN if 19. Display this. It has no configuration. So IP address here will be 192.168.19.254, the mask of 24. We tell it DHCP. Before we tell it DHCP select global, let's quit and create the DHCP on the global view. So DHCP enable, then enter that sub VLAN if interface. Tell it DHCP to select DHCP select global. We enter for VLAN if 20. Give it IP address of 192.168.2.254. The mask of 20. Tell it DHCP select global, for that interface to be able to identify which addresses to be assigned. So having done that, we are through with setting up the DHCP on AC. So we are going now to get into WLAN configuration. Before we get to WLAN configuration, we need to set up the upper network. We need to ensure that the upper network is running. So when you display this, you see on this switch only STP has been enabled, but we will not configure the VLAN batch for VLANs to pass. So we're going to enter that switch. We've only allowed those interfaces, but now we've not configured them. The VLANs, we will not enable VLAN source. say VLAN batch 2 to 20. So remember when we were setting up the VLANs for the interface, we forgot to enable VLAN batch 2 to 20. So please rectify that. If we don't enable VLANs on this switch, meaning that the network for the trunk won't be able to allow to pass. So I have done that. Now we are going to get to our AC. So on AC, we are going to begin with our WLAN configuration. So you should know how to configure WLAN steps. We are going to start with creating the AP group. So AP group name here, they told you to use a group name of default, then the verb is P1. Regulatory domain should be default. Country code should be CN, that is for China for the default. SSID should be S1 and SSID name is ICT. Security profile is S1. Security profile policy will be WPA, WPA2, PSK, AES, then password is Huawei at 123. Verb profile will name it P1, forwarding tunnel mode is used. Then service VLAN is VLAN 20 SSID. This one has been bound to that verb. Let's get and configure that. So AP group name here will be default. After you create the group, quit and create the regulatory domain. Regulatory domain name here is also default. Country code here, they said CN. That is the default one. Quit and bind the regulatory domain into the AP group. So enter the AP group and regulatory domain. We're going to bind the regulatory domain into that AP group. So say AP profile, say regulatory domain default. Say yes. After that, quit. And we are now going to add the MAC address authentication into that AP group. So AP authentication mode here, we said we use MAC authentication. Then AP MAC, we are coming to copy the MAC address of this AP. So let's copy that MAC address, Control C, and paste it, Control V. And we are going to, can you give it AP name? AP name here, you can give it area 1. Then bind that MAC authentication into the AP. So AP into the AP group name here was default. Say yes. So display AP all. The status is still idle. Why? Because we've not configured CapWap source. So quit and configure CapWap source. Quit CapWap source interface. Here will be VLAN 19. Source interface, CapWap source interface, VLAN 19. And display again. Status is still idle because because the interface keep on going on and off. So let's display DHCP, display DHCP server statistics. So clients requests 3 have been made, 3 requests, DHCP discover 2, DHCP request is 1, then DHCP server reply are 2, and the offer, it has offer 1 address. Let's display again the AP. Now you see here, now the AP has obtained an IP address of 192.168.19.26 and state is config. State should be normal. but it has obtained an IP address. So let's enter into the WLAN and reset that AP reset all. Say yes. Success count 1, failure count 0, meaning that AP is now running successfully. The AP is running, so display AP all. Fault. When you see fault here, meaning that our device is working, it will be normal soon. So as we now see, it already obtained an IP address on this of 192.168.26. Now we are going to proceed with the WLAN service parameter configuration, like we said, configuring the security and SSID. So SSID profile name here was S1. Then SSID name was ICT. Oops. That is the name that will appear, the name of the Wi-Fi that will appear when you want to sign in. Then you quit and create the security profile name here. It will be the same with the SSID, that is S1. Then security WPA2 PSK passphrase. Here they said use passphrase of Huawei. Shift at 1, 2, 3. Then AES. Quit and create the VAP profile. So VAP profile name here was P1. On the VAP, we are going to bind the SSID name S1. Then security profile we are going to bind will be S1. Then the forwarding mode here will be tunnel. Then service VLAN. Service VLAN, they said VLAN ID was VLAN 20. So here normally it's good to understand the VAP. So we bind all the configuration for the security and the SSID into the VAP. Then we are going to bind the VAP into the AP group. So it's like in the department, if you are an employee, you report to your head of department. Then the head of department will now report to the HR. So head of department here is like the VAP. All the problems are being delivered to the HOD. Now the HOD will now report to the HR. So the HR here will be the AP group. It will collect all the problems from the HOD. So now we will bind the VAP into the AP group. So quit. Then we are going to enter AP group. AP group name here was default. So tell it VAP profile name here was P1 WLAN 1, then radio 0. The first circle for the first channel should come up after this configuration is set. You see the first circle has come up. Now we are going to configure for radio number 2. So VAP profile was P1 and WLAN here was 1, then radio here will be radio 1, and we should be able to see for the channel number 2. Okay, good. Now our WLAN. Now let's see if this PC can be able to find the network. So we can see here SSID is ICT. Let's see now if you can connect it. It is asking for a password. The password we just configure was Huawei. Shift at 1, 2, 3. It's obtaining an IP address. The link disconnects. Let's connect to channel 2. Huawei at 1, 2, 3. It is connected now, meaning it has obtained an IP address. So let's see the IP address that it has obtained from the DHCP server. So IP config it has obtained an IP address of 192.168.2.19. We said it is operating on VLAN 20, that is for 192.168.2.2.0. That one was the network for the STA. So we were told now the AP, the station here, after it has connected to the network, it should be able to ping the firewall interface. So that is what was said here. Configure the switches on the internet so that AP can communicate with AC, and STA connected to the AP can communicate with the gateway firewall after connected to the WLAN network. So while on this STA, you should be able now to ping the interface on this firewall. The interface on the firewall is 4 gig 105.2. That is 192.168.2.2. Should be able to ping. Now let's see if we can ping that. So ping 192.168.2.2. Destination unreachable. Why? Because firewall, on this interface, we should now be able to enable ping permit on that interface, that sub interface. So enter the firewall admin. Password here will be Huawei. Shift at 123. Enter the both the interfaces. So interface gig 1/0/5. Display this. So we've enabled ping permit on that interface. So you should also enable it on gig 105.1. Let's see the 105.1. Display this. So on 105.1, the ping permit has not been enabled. So service manage enable. Then gig 105.2, display this. Service manage is also not enabled. So service manage enable. Service manage ping permit. Also on gig 101 should enable ping permit. Let's now see if now after we enable ping permit, this can ping that destination host unreachable. I guess that is because of the software. You see now that interface is down, but it should be able to ping. Let's see if this PC can be able to ping the firewall. So ping 192.168.1.2. Destination unreachable. When you tell destination unreachable, meaning just packets are just being dropped, but unless it tell you request unknown, but this one is telling you destination unreachable, meaning that this link keep on going down because firewall and the software is lagging the PC, so dropping the packets. So suppose your PC is powerful, you should be able to see if this one should be able to ping this interface on firewall 1. When I've configured this network while I was not using the screen recorder, while I was not recording, I was able to ping even the server. So ensure that you follow all the configuration on this lab. If you follow every point and configure everything correctly, we will be able now to test your network very well, and the network should be able to reach the respective interfaces. You should check on something here. On this router, I said a network of 172.16.1 should be changed because originally I configured on this interface while I was adding it to the OSPF. I mistakenly configured 172.168.1. So that one should change to .16, not .168. So request timeout. If you're told request timeout, meaning that it doesn't know where that network is. But when destination host is unreachable, meaning that the packets are just being lost. Let's see this other one. Request timeout. So I can try and stop this other Let me stop this other firewall, because in case firewall 1 goes down or firewall 2, the network should be able to operate still in a normal way. So if firewall 1 goes down, firewall 2 will take over the role. When firewall 2 is down, firewall 1 will act as the active firewall. So we want to test network. That's why we are stopping one firewall to ensure that the link towards firewall 1 is operating. Let's now try to ping. You see here now packets are now able to go through, because now the system doesn't lag now. So we are now able to ping the gateway of the firewall as the practical required. You now, after this station connect to the network, should be able to reach the gateway of firewall 1. Let's see also if our web client here can now reach firewall 1 interfaces. Now you see it is now able to ping. The packets are just being dropped because the interface is down. It goes on and off, stops, comes on. Our lab is now complete. We've finally reached the end of this lab. We've configured everything that was required according to the lab setup. So after every configuration, it's always good to verify your network, see if the PCs are able to reach each other, and also if the web client on the internet can be able to access the VM1 and also the web server. So we come to this firewall, you see. When you look at here, I was able to ping 172.16.1.1 to test that network where we want to, in a case where we want to ping this other network. So like server 1 is on a network of 172.16.1.1 and client 1 is on a network of 192.168.1.1. We want it to traverse through this network and reach the server. So that's the part we are implementing by the testing the links. You see here, destination and reachable. Look at the interfaces. Let's test it again when the interfaces are destination and reachable. But when you look here, there was a test that I did before when I stopped my software. Look at here, PC1 was able to ping the server, which is on a network of 172.16.1.1, and also it was able to reach this network of 30.1.1.2. That is the interface on gateway router that connects to the firewall. Those were the interface that we were able to test, meaning that before interruption in the software, the interfaces were able to reach each other. So if you followed everything I demonstrated in all of this lab and you have a PC that will be able to support both the devices, you should be able to ping the server from the web client. That's all about this lab. Let's meet in the next more coming labs that will be helping you to understand more on configuration on a large scale network. So thank you.